I congratulate the French Academy and also the academies of the African, Mediterranean, and European region who are in the process of launching a major initiative of improving education for the sake of science, for the sake of development. But here I represent the IAP for Science, the global network of 111 science academies, and I will say both a little bit of my own experience from my background of India, how it pursued this, and also the role of science and technology in the development process. The main issue is that the academies, all the science academies, starting with the InterAcademy panel of about 13 academies, it has now 111 members, which we call Global Network of Science Academies. But in parallel, we had also academies of medical sciences and an organization, InterAcademy Council, which undertook long studies and produced valuable reports. The question was, can all of them come together to form one body, which we now call InterAcademy Partnership, which has been registered as an independent body in US early this year. And with the IAP for Science work through 4 regional networks, one of course in Africa. It starts, if I say, with Asia Pacific ASA, in Europe, ISAC, then in America, the IANAS, both South and North America, and in Africa, NASAC, and as I said, 111 in science. And if we put together the medical academies, the InterAcademy panel or IAP for health, then we are more than 130 academies because IAP for health had common between IAP for science. And we are also planning or working to bring in engineering and technology into it. So if we look at the geographical distribution, one challenge remains that some parts are still devoid of academies, particularly in the region of Africa. In Asia, the Arabic Peninsula is also one of the challenge, how to bring them into the network of science academies because they don't have their own national academies at the moment. Similarly, if we look on the right-hand side, in the case of IAP for health, similar kind of gaps are observable even here. For example, the Arabian Peninsula and large parts of Africa are not yet into our network. Now, in the context of the now Sustainable Development Goals, we are, of course, very much concerned about quality of education, not merely education, but quality of education, and particularly in the developing world. And those, even in the developed world, are now worried because in academies there is often a discussion how much we are able to attract the brightest of students to the science stream. This is a challenge across all the academies, all the nations, whatever is their level of development, particularly true for developing world. Now, in this is the core, but if we go for other, even the sustainable goals, education is there. Education is all pervasive, but this is more focused on this. And IAP also tries to work out what we should do so that in about up to 2030 we make substantial progress, the world becomes much better than what it is now. Now, many countries have made a lot of expenditure on military resources, but the major challenge is still there, whether it is the climate change leading to the extreme events, also diseases where particularly those which we are not able to treat by the usual antibiotics, they are becoming resistant. And this is a major challenge for all dealing with science research and development, poverty. And these are such things which cannot be solved by forced military intervention. This needs high quality of science input, high quality of science, and finally also emerging from the educational institutions. For achieving the SDGs, there is a need for scientific research to underpin movement towards the targets of SDGs. As I mentioned, it is not merely one or two, but it is underpinning the entire spectrum of goals that need to be achieved. There is a greater need today than ever before, that the link between scientists and decision makers has to be strong so that best available scientific advice is available to those in political leadership, in administrative leadership in the countries. And in fact, I was very happy to see that you had invited the Minister of Science, Technology, Education in the morning. It's a very good decision, and this is very important that we keep link with the decision makers and also the scientific community. A scientifically literate society, so that people can make informed choices. It is the more they do, the much better it is, and also needs improved standards of science education in schools. India, for example, is still a developing country, but making quite a bit of progress. I may mention that at the time of independence in 1947, we had about 350 million as a population, and the British, when they left, we had only 18% literacy, which essentially means that bulk of the people were illiterate. In 2011, it reached nearly 75%, but still 25% is a challenge. And that 25%, if you look, it is like a country like US population. But at the same time, if you look, more than 850 million people getting reasonable base level education, and also now nearly 200,000 scientists with 6th place in publication. There is a good progress, but we are not happy, and we keep on pressing the government to go above 1% of GDP for science. The investment has increased, but GDP has grown, so we want more money. That is the challenge with all the developing countries. IAP has fixed strategic priorities. These are 4. One of that is, of course, that is why I mentioned about literacy, that we should try to build a scientifically literate global society. All society with the thought process is scientific, base is scientific, so that you are not distracted from the core values of science while making decisions and also pursuing your own sphere of life. Provide evidence-based advice and perspectives on global issues. This remains one of the biggest challenges I feel. I feel also in Europe, I feel in Asia and others. For example, what should we do with the genetically modified organisms? It is not only the scientific issue, it is also the perceptions and how people perceive and they want to show and so on. So this is one thing which needs that we have to not only strengthen our scientific enterprise, but also we have to create, this is our duty, the sufficient ambience through evidence-based systems so that people can make choices, make decisions which are based on them. The global network, we wish to strengthen. New academies are to be created in countries where they are not yet present. I gave you a global picture in which we find a lot more is to be done in African countries and also some parts of Asia, the Arabian Peninsula and nearby. Now, science education, we have a dedicated science education program. This is IAP's SEP. It is because this is our priority number one, build a scientifically literate global society. And very eminent people have been associated and very committed people have been doing work across the globe on this issue. So, for example, inquiry-based science education since 2003, very remarkable progress also has been made in Australia and elsewhere, where I saw in schools how even 10, 12 years old students would be directly doing this thing. So in this, there is an issue, which I will say a little bit later, that you must emphasize more in experimental work at the beginning in our education, teaching, and this will launch into the research arena. The science education program was established 2003, high-level global council and observers from different regions, they are guiding it, and our chairs include Jorg Lende, Pierre Eliana from France, and presently from Malaysia, Dato Li Xiong is the chief, and he is also very enthusiastic, very active on this. So as you can see, the cover is very broad. If you see both from Europe, Americas, Africa, you can see it is all very broad cover. Also, France has been playing very good role for this thing. And more recently, what I want to emphasize that we are also involving the Global Young Academy. For example, the co-chair is a member. So we give a lot of emphasis that all levels of leadership must be involved in this thing. This I mentioned to you. Right now, we have Bruce Alberts from US and Professor Kire from France. He has been very active in IAP once we served together in the membership committee, and also other people like from South Africa, Professor Dayaredi, Senegal, and from Asia, Malaysia, Egypt, and so Egypt in Africa, of course. So this science program is the main focus, as I said, is inquiry-based learning. And some of this has been very successful, particularly the Australian Academy, at least in our part, has done a remarkable job of nearly 25,000 schools have been involved in this thing. Now, we have a lot of accomplishment, promotion of inquiry-based science education. We have a biennial conference, and in addition, there are regional conferences like AEMASE and other workshops, and from time to time, there are declarations and recommendations and publications coming out of this. So this is something which we value very much. For example, the Beijing Declaration on Science Education and Science Literacy, this has been very well received and still is cited in many different forums. Now, the AEMASE, the first meeting in Rome in 2014, started this thing. We followed it in Senegal in September 2015, and now the third part here, and IAP would look forward to some more tangible and positive results coming out of this. And as you can see, we have 3 publications coming out of it, and these publications find a very good place all over the world, both in academies and outside the academies. Some of the key figures now, the present chair, Professor Lee. And you can see some of the familiar persons. One of the aims is that we have to make global connections. So there is a lot of initiative from China, whether they can, in this new initiative to make some kind of a Silk Road push, whether this program can also be taken up along with other activities. And within days, for example, whenever there is a problem like the break of the Zika outbreak in Latin America, the IEP members had collated wide range of teaching and information material, and that is what our strength is. When you can take this issue to your school children, and I have now to conclude, so I maybe give some important issues just to highlight. Today, for education, some of the key issues are the rate of generation of new knowledge is very high, and we have to keep pace with it in our classrooms. Then one of the things which was also mentioned in the introductory part, that one of the challenges all academies have, how to bring the best students, the brightest ones to science, because now there is a lot of competition for different streams, and this particularly for the developing world. The emphasis on innovative experimental opportunity in learning science subject is very important. For example, if you teach students on something on X-rays or diffraction, there must be demountable X-ray tubes, units. You can see, you have parts connect, you can make X-ray source, you can make diffraction, you can see even a biological structure in the laboratory. This is doable, but we need to create the systems where it can be done. In the end, I quote from a report on education from India, Kothari Commission, one of the great physicists and founder of Indian education system after independence. This is true even today. The characteristic of a world permeated by science, that is some essential ways the future shape of things is unpredictable. This emphasizes all the more need for an education policy which contains an inbuilt flexibility so that it can adjust to the changing circumstances. This is our contact, and I acknowledge contribution of our Dr. Peter McGrath from IEP Secretariat, Trieste. Thank you very much. Thank you.